In this topic, we're going to have a look at the chi-squared test in biology. So by the end of this topic, you should know what is the chi-squared test and how do we use it in genetics. If you toss a coin 100 times, it would be reasonable to expect it to land on heads 50 times and on tails 50 times. Now in practice, it would be unusual if these exact results were obtained. So if you got heads 55 times and tails 45 times, does this mean that the coin is weighted or biased in some way? Or is it purely a chance deviation from the expected result? And how can we test which of these two options is correct? We use something called a chi-squared test. So the chi-squared test is used to test the null hypothesis. And the null hypothesis is used to examine the results of scientific investigations. So it's based on the assumption that there is no statistically significant difference between sets of observations. And any difference would be due to chance alone. For example, the results that I obtained compared to what I expected to get, the null hypothesis would say that there's no difference. So what would the null hypothesis of the coin toss be? That there's no difference between the number of times the coin lands on its head and the number of times it lands on its tail. So the chi-squared test is a means of testing whether any deviation between the observed and expected numbers in an investigation is significant or not. Okay, so it's used to test, as I said, whether any deviation between the observed and expected numbers in an investigation is significant or not. So we'd test whether the difference in the results that we got from the coin tossing and what we expected was significant or whether it was due to chance. Here we have the chi-squared formula. It's equal to the sum of the observed minus the expected squared over expected. And if you've only got two values, you have the sum of observed minus expected minus 0.5 squared over expected. Now once you've got that chi-squared value, what do? You use it to read off on a chi-squared distribution table. And this is used to determine whether any deviation from the expected results is significant or not. Now this table looks complicated, but it's quite simple. So on the left, you've got the degrees of freedom. And this is the number of categories that you have minus 1. So for example, I've got 6 categories and a chi-squared value of 8. Is the difference that I found significant or not? So what's the first thing that you do? You're going to have a look at your degrees of freedom. Because I have 6 categories, my degree of freedom will be 6 minus 1, which equals 5. I then look up the chi-squared value that I obtained in the table. So what you do is you have a look at the degrees of freedom, which is 5. You go all the way across and you look where 8 falls in the table, and you'll notice that 8 falls between 7.29 and 9.24. Then you need to have a look at the probability above that. So the probability is 0.2 and 0.1. So keep this in mind. So in the chi-squared test, you've got a critical value of 0.05 or 5%. This means that any difference is 5% due to chance. If the probability that the deviation is due to chance is greater than 0.05%, 0.05 or 5%, we say that the result is not significant and the null hypothesis would be accepted. If the deviation is less than 0.05 or 5%, the deviation is said to be significant. In other words, some other factor is affecting the results. So the null hypothesis must be rejected. Going back to our example, would I accept or reject my hypothesis? And is the difference significant? Now my chi-squared value of 8 falls between 7.29 and 9.24. This means it falls between the probability of 0.2 and 0.1. So this probability between 0.2 and 0.1 is greater than 0.05. So I accept the null hypothesis and the deviation from the expected results is not significant. So it's due to chance alone. Okay, let's have a look at a question. If I cross F1 plants producing round yellow seeds that are known to be heterozygous, and I got 315 round seeds, yellow seeds, 108 round green seeds, 101 wrinkled yellow seeds, and 32 wrinkled green seeds, is this variation due to statistical error, or could some other factor be the reason for the difference? So the first step is to write down your null hypothesis. There is no significant difference between the observed and the expected results. So here you've got a table of observed results. How do you calculate the rest of the table? So what you do is you add up all your observed results. So you get a total of 556. Now you know from the test crosses that you would expect a ratio of 9, 3, 3, 1. So how do you calculate the expected results? What you do is you total up the predicted ratio values so that you can calculate the expected results. I'm going to calculate the expected value of round yellow seeds. So what I do is I use the ratio of 9 divided by 16 times by 556. So I get a value of 312.75. So what I want you to do is press pause and complete the rest of this table so that you can compare your results with what I've just got. Okay, here are the results that you should have got. Now the next step is to add up the last column. So when you add up the last column, you should get a chi-squared value of 0.48. Now we need to see whether this value is significant or not. So what are we going to do? Well, the first step is to calculate your number of degrees of freedom. So you've got 4 categories. That means that there must be 3 degrees of freedom. Then you look up your result in the chi-squared table. Since you've got 4 categories, therefore there must be 3 degrees of freedom. So you look up in your table 3 degrees of freedom. Your value is, or my value is 0.48, and this falls between 0.35 and 0.58. What probability is this? And is this probability higher than 0.05? So remember that values higher than 0.05 mean that our result is not significant, so we can accept the null hypothesis. So since 0.48 falls between the probability of 0.95 and 0.9, our result is not significant. So we accept the null hypothesis. There's no significant difference between the observed and the expected results. Okay, in summary, the chi-squared test is used to test the null hypothesis. And remember that your critical value is 0.05. So you put the chi-squared value that you got into the table, and then you look where the probability is. If the value falls in the table, which gives you a probability higher than 0.05, we say that the result is not significant, and we therefore accept the null hypothesis. And that concludes our lesson, the end.